Spatially varying force. A net force along the x-axis that has x component F sub x equals minus 12 newtons plus 0.3 newtons per meter square parentheses x square is applied to a 5 kilogram object that is initially at the origin and moving in the minus x direction with a speed of 6 meters per second. What is the speed of the object when it reaches the point x equals 5 meters? So the work done by the net force acting on this object will be the integral from 0 to x, the net force F net x dx. This is the integral from 0 to x m dv dt, mass times acceleration dx, which is the integral from initial velocity to final velocity m v dv, because dx dt is v, so this becomes mv dv, and this is 1 over 2 m v final square minus 1 over 2 m v initial square, which is the change in the kinetic energy. So this result is known as work kinetic energy theorem. Okay, so that's what we are going to use. So the work done by this net force acting on the system is from x equals 0, integral x equals 0 to x equals 5, the force acting on the system minus 12 newtons plus 0.3 x square dx. This is minus 12x plus 0.3 x cubed divided by 3, which is to be evaluated between x equals 0 and x equals 5. So this would be minus 12 times 5 plus 0.1 times 5 cubed. So this gives us minus 60 plus 12.5, which is minus 47.5 joules. Therefore, the change in the kinetic energy, delta K, is 1 over 2 m v final square minus v initial square is minus 47.5 joules. So we find that v final square minus v initial square, the initial speed was 6 meters per second, minus 6 square is equal to minus 2 times 47.5, because it's a 5 kilogram object, this is divided by 5, that gives us minus 19. So v final square is 36 minus 19, so v final is square root of 36 minus 19, which is 4.12 meters per second. So this is a direct application of work kinetic energy theorem. Okay, so let's see what we did. We have a net force along the x-axis that has x component given by this expression, this is applied to a 5 kilogram object that is initially at the origin, so x equals 0, and moving in the minus x direction with a speed of 6 meters per second. What is the speed of the object when it reaches the point x is equal to 5 meters? So the work done by the net force is basically equal to the change in the kinetic energy. This is work kinetic energy theorem. So the work done by the net force here will be minus 12 plus 0.3 x squared dx integral from 0 to 5. So we go from x equals 0 to x equals 5. So minus 12x is the integral and plus 0.3 x cubed over 3. This is to be evaluated between 0 and 5. That gives us minus 47.5 joules. When we check the change in the kinetic energy, 1/2 5, we final square minus 6 square must be equal to minus 47.5 joules. So we find the final speed 4.12 meters per second. So the initial speed was 6, the final speed is 4.12 meters per second.